So for problem number 4, we have the given for capacitance, which is equal to 100 microfarad, and for the VB, which is equal to 50 volts, we have the resistor, the RL, resistance of the load, which is 5 ohms, and then we have the frequency of 1 kHz or 1000 hertz. So this is our given. So we have to sketch the scale and the waveform of the current. So first thing first, we cannot solve the current, we cannot scale it without finding its time and the maximum and minimum of voltage. So first we have to find the time. The formula for finding time is 1 over F. So therefore 1 over F is 1000. So this would be 1 millisecond. So after finding the time, we have to solve for the CR, which C times R. So with respect to time, so C times R is 100 times 10 to the power of negative 6, because it is micro, times resistor of 5 is equal to 0.5 milliseconds. So, and then after finding the T and CR, we have to find the maximum with respect to voltage. So in finding that, the formula is VB over 1 plus exponent raised to negative T over 2 times CR. So this is the formula in finding for the maximum value of the voltage. So therefore VB is 50, and then 1 plus e raised to negative T is 1 over 2 times 0.5. So therefore it is, if you calculate this in the calculator, we will get the answer of 36.55 or 36.6. So this is the VC1 for the maximum value. So let us erase. So we have now 36.6, and then for the minimum value, we have the formula of VB times E raised to negative T over 2CR. So therefore VB is 50 times E raised to 1 over 2CR. 2 times 0.5. So therefore 50 times E 1 over, this would be 1, 2 times 0.5. So therefore raised to negative 1. Then the answer would be, if you calculate it, would be 18.4 voltage. So we have now the maximum and minimum voltage. So let us try to now we have to scale and sketch the current. So we have the V for maximum, we have equal to 36.6 V. We have the V minimum 18.4 V. But first thing first, we have to solve the I. I almost forgot to solve the I. So I for the maximum is equal to 36.6 divided by 5, because just like interrelating Ohm's law, I is equal to V over R. So 36.6 divided by 5 is equal to 7.32 amperes. And then for the I minimum is 18.4 divided by 5 is equal to 3.68 amperes. So we have now 37.32 and 3.68. So to put it here, the I let us denote as I max is equal to 7.32, and then for the I minimum we have 3.68 amperes. So now we have this these values. I will just put the time is 1 millisecond, and the CR is equal to 0.5, and this CR value would be the basis for the spacing of the scales. So what I mean is this. So now we're now ready for scaling the current and its waveform. So we try to scale. So now this will be 3.68. This will be respect to TMS. So like what I said, from 0, 0.5, 1.5 to 2.5. So then this will be the I. Then from here our maximum and minimum voltage would be negative 7.32, and then for the positive 7.32. So try to sketch or scale that so we can draw that here from here. Then during the negative, no 1.5, and then 2. Then from negative it's like this, and then again for the positive, and then for negative it will be. So now this will be the scaling and the waveform for the current. So as we know, this will be the positive or the maximum voltage 7.32 and the negative 7.32, and then the current positive, the maximum and negative current, and lies into the 3.68 as per minimum in the current waveform. This will be the maximum and this will be the minimum waveform of the current, and from 0 under this will be 7.32 maximum, negative 7.32 for negative, and the 3.68 as under the 0 or below the 0 waveform. That's all. Thank you.